Hey guys, what's up? Welcome to TSK Tutorials, and this is FPS 1.34, and I'm doing a little bit of dog sitting for a week.
Are you guys excited to be famous? You're gonna be on the internet! Yay!
Okay, fuck this. Alright, so in our last episode, we learned how to basically write a map of what the shortest distance is to go from all the different places in our map to all of the other places in our map. And we have those saved inside of arrays that are saved inside of all of the different door scripts. So now we need to create an enemy that can read this map and decide from where they are, figure out what the shortest route is according to this map to get to the player and the cell that that player is in. So basically the way this is going to happen is the enemy is going to keep track of what cell it's in, and then the player is going to keep track of what cell it is in, and then the enemy is going to reference the player movement script to find out where the player is or what cell the player is in, and then the enemy is going to look at all of the available doors that are physically touching the cell that that enemy is currently in, and then it is going to see which of those doors has the shortest route to get to the player, and then proceed to move towards that door. But we're not actually getting into the movements just yet. That's going to be our next episode. This episode is just going to be focusing on choosing which door it is. So we're going to be able to go into the inspector and actually look at what door it chose to determine whether or not it's working. Whereas our next episode, we will actually get to watch the enemy move and actually follow exactly where the player goes. Alright, so let's actually take a look at the scripts that we're going to be making in this episode, or not making, but modifying, or we're going to be making the enemy movement script and we're going to be modifying the player movement script. So to modify the player movement script, we're creating a variable called current cell, and this is of type GameObject, and this variable is going to remember what cell the player is currently in. So to actually save what cell the player is currently in, we're going to do function on trigger stay. Now remember, function on trigger stay is called every frame, or almost every frame, that the player is in contact with a collider that has isTrigger set to true. So a trigger is a game object that can detect collisions, but it doesn't interact with the physics engine. Alright, so we have right here function on trigger stay, and we have inside of the parentheses hit trigger of type collider. So basically what this means is that everything inside of here, whenever we reference the variable hit trigger, we are referencing the collider that is the trigger that we entered into. Alright, so actually inside of function on trigger stay, we simply have if hit trigger dot tag. So we're taking a look at the collider that is the trigger that we just hit, and then we're accessing the tag that game object is tagged as, and if it equals AI path cell, then we're going to set current cell to hit trigger dot game object, or we're going to access the game object that the trigger collider that we hit is attached to. Alright, now let's take a look at a new script that we're going to be creating, and this one is called enemy movement script. And the first variable inside of enemy movement script is just like in the player movement script that we just did up here. We have a variable called current cell, and this is of type GameObject. And this one is going to save the cell GameObject that the enemy is currently in. Alright, next we have a variable player movement script, and it is of type player movement script. So you want to keep a very close eye on the P in the beginning, because if it is lowercase, it is a variable specific to the enemy movement script that is just saving the actual player movement script to make the engine run slightly faster, but also just to make it shorter and easier for us in the code. Alright, so our next variable is player cell. So player cell is of type GameObject, and it is going to remember the cell GameObject that the player is in. So basically this is just going to copy and paste whatever the player movement script's current cell is set to. Alright, next we have a variable called goal door, and this is of type game object, and it is going to remember the AI path door game object that leads us to the shortest path to the player. So basically this is just kind of like a starting point, and this is the variable that we want to change to the correct door that we want the enemy to be able to navigate their way through. Later on, we're going to make goal door a actual goal for that enemy to move towards, and then once it gets to that door, then it gets into a new cell, and then it creates a new goal from there, and then it finds its way to the player that way. Alright, next we have a variable called shortest path so far, and it is of type integer. So basically what we're going to be doing with shortest path so far is first we're going to set it to infinity, and then we are going to look at all of the doors that are available, or all of the doors that are physically touching the current cell that the enemy is in, and then it is going to first go to the first one on the list and be like, how many doors do I have to go through to get to the player from this door? And because any real number is going to be smaller than infinity, it's going to save that door and how far you have to go, or how many doors you're going to have to go through to get to the player from that door. And then once we move on to the next door, if that door has a smaller number, then we will save that door until we go on through the whole list. And then after we go through the whole list, we will know which door has the smallest number of doors that you have to go through to get to the player. And our last variable is wait to start, and it is of type integer, and we're going to by default have this set to 5. So just like in our last episode, FPS 1.33, we had a wait to start variable just to make sure that the map was written, or no, I mean in this case we're waiting for the map to be written. In our last episode we were waiting to make sure that we had the lists of all of the cells and doors all set up in the game before we start organizing and analyzing those lists. Whereas in this case, we're going to make sure that the map has been written before we actually try to access that map and find our way through the level that way. Alright, now let's take a look at what is inside of function awake. Now remember, function awake is called whenever this game object is created. So that means if you spawn enemies in the middle of the game, this will still work, as opposed to if you used function start. Function start is called at the start of the game, or it might be at the start of the scene. I'm pretty sure it's at the start of the scene or the level. So you want to make sure that this is set to awake and not start, because if you set it to start, that's going to cause you some issues when it comes to spawning enemies, as opposed to having those enemies already be there when you start your level. So let's take a look at what is inside of here. So first of all, we're setting shortest path so far to infinity, and we're simply going to write that by shortest path so far equal mathf.infinity. So mathf.infinity will just return you infinity, and now we have the largest possible conceivable number saved inside of the variable shortest path so far. So now we know any number that we compare next to shortest path so far will be smaller than infinity. Alright, so our next line is player movement script equals, and make sure you pay attention to the lowercase p right here, because this is the variable that is specific to the enemy movement script that is saving the location of the player movement script, just so that it is quicker and easier to find later on in our code. And we're going to have it equal game object, and this is the class, because we're just accessing the function from the class find with tag. So game object.finding with tag player, and we're only going to have one game object in our scene that is tagged as player, and then we're going to get component from that player movement script. Now make sure you notice the P is capitalized right here, and this is written exactly as I have it spelled, the actual file that is the player movement script. Alright, now the last line of code we have inside of the function awake is wait to start equal 5, and wait to start equal 5 is just there just in case you happen to change it in the inspector or anything like that. It's basically just kind of like a backup just to make sure that wait to start is 5, or at least a number that is large enough that the enemy movement script is going to wait long enough just to absolutely make sure that the map has been written before the enemy starts to try to read that map. Alright, so now before I go into function awake, I want to go down here to function on trigger enter. So function on trigger enter down here is going to act extremely similar to what we put inside of the player movement script, but up here we have on trigger stay, and down here we have on trigger enter. And I'm trying to remember if there was a reason why I did on trigger enter as opposed to on trigger stay, but I don't think that's going to make a huge difference, and I will tell you in the screen recording if it does make a difference. And I can't remember if I changed it to on trigger enter for a particular reason, but either way I'm pretty sure it's still going to work. So in here we have function on trigger stay, and inside the parentheses we have the variable called other, or I guess we probably could have called it hit trigger, but in this case I called it other, and it is of type collider, and this is going to remember the collider that we entered into that has is trigger set to true. And inside of the function itself we're going to have if other.tag equals AI path cell, current cell equal other.gameObject. So literally almost the exact same thing as we have up here. Basically, if the tag that is attached to the game object that this collider is attached to has a tag of AI path cell, we are going to save the game object that this collider is attached to in the variable current cell. And remember, in this case, since we're inside the enemy movement script, current cell is going to save it inside of this variable up here inside of the enemy movement script. Alright, now let's actually take a look at what is inside of function update. So first of all, we have an if statement that all of this code here is inside of, and the if statement is if wait to start is smaller than or equal to 0, and we have outside of the if statement. So remember, this one line of code is run every single frame regardless of what's going on, and it is wait to start minus equal 1. So from the very beginning of the game, ever since the first frame, it's going to keep on doing this. It's going to keep on counting down from 5, and after it passes 0 and goes into the negative numbers, this if wait to start is smaller than or equal to 0 will return true, and then all of this code here will be run. Alright, so the first thing we want to do, because the player cell, or the cell that the player is in, is probably going to be changing a lot because the player is going to be moving around and navigating his or her way through the level. Let's not be sexist here, I'm going to say his or her, even though I'm pretty sure like 99.9% of my viewers are guys. But anyways, so we're going to have player cell equal player movement script dot current cell. So current cell inside of the player movement script is set every frame that the player is inside of a trigger, and then so we're accessing the current cell from the player movement script, and this is the variable, the lowercase p right here, player movement script that we have set up here. So we're accessing the player movement script, and we're accessing the variable current cell out of that, and we're saving it inside of player cell so that we can access it later inside of this code here. Alright, so first of all, let's take a look at our first for loop here. So this for loop is going to be going through all of the doors that are physically touching the cell that the enemy is currently in. So we have var door checking now, and that variable is of type game object. So we're declaring a variable for this for loop called door checking now of type game object, and we're going to have that in. So we're going to be swapping that through this array here. And remember, doors is an array that is saved inside of the AI path cell script that saves all of the doors that are physically in contact with that cell. So we have current cell, the cell that the enemy is currently in, dot get component AI path cell, so the script of the cell and we're accessing the array variable doors out of that. So door checking now, every time we run through all of this code here, we'll swap out to the next item on the list inside of the array doors. So basically what we're doing right now is we're having the enemy look at all of the available doors that that enemy can walk through according to what cell that enemy is currently in. And for each of those doors that we look at, we're going to go through another for loop. So this for loop is going to declare a variable called I and is an integer, and we're going to start it out at 0. And then here's our condition right here, this long condition here. And that, so if this condition is true, we're going to run all of this code here. And that condition is if I is smaller than or equal to door checking now dot get component AI path door dot cells dot length -1. So I think actually, I don't know, that this is a little bit redundant because every single door is going to have the same length of cells inside of that array, so it doesn't matter which door we go through. We just want to make sure that I goes through to a number large enough to represent the total number of cells in the scene at this current time. But we don't want it to go too high where it's going to start accessing or trying to access items out of an array where that array just doesn't have that number of items in its list. If that happens, it's going to give us back an error. So that's why we need to do cells.length -1. So we're just going to take the door that we're looking at now, so door checking now, get component AI path door, so we're accessing the AI path door script out of that, and then we're going to get the array variable cells from that, and then we're going to get the length of that array, and then -1 from it, because every array starts at 0 and doesn't start at 1. So when you count something, you're thinking like 1, 2, 3, 4, and your brain counts that way. But arrays count starting at 0, so it goes 0, 1, 2, 3, 4. But length includes 0 as one item, so it's going to count that as 1. So if we have an array that is of length 2, that array is going to start on item 0, then item 1, and that is 2 items. So that is how that works. And then the last part of this for loop is I++, and plus is short for plus equal 1. So basically we're going to increase I by 1 every time we run through all of this code here. Alright, so as we're running through all of the code that I have highlighted right now, basically what we're doing is we're going through the list of all of the cells that are in the scene. And so the first if statement we have inside of this for loop is if door checking now dot get component AI path door dot cells I inside of square brackets equals player cell. So door checking now, remember we are going to be checking, and that is this for loop here. We are checking all of the doors that are physically in contact with the cell that the enemy is currently inside of right now. And then we're going to get the door script from that. And then we're going to get the array cells from that. And then we're going to go to item I. And remember, I is going to count up from 0 the number of items that are in this list. So we're going to access this particular item on the list. And if it equals player cell, now we know that we are looking at the cell on the list, or on the list according to that door, because that door has part of the map written into it. So it has the map according to that door, where to get to all of the different cells, and how many doors you have to go through to get to each of those cells. So we're looking at the cell that we want to get to, and that is the player cell. Alright, so with this if statement, now that we know that we accessed the cell according to our map, or so we've basically found the cell that we want to get to on our map, and now we got to see how far away it is. So we're going to do if door checking now dot get component AI path door dot doors to cells I is smaller than shortest path so far. So door checking now dot get component AI path door, same is up here, but instead of accessing the array cells, which is the list of all of the cells that are in our scene, we're going to do doors to cells, which remembers integers that tell us how many doors we have to go through to get to each of those cells. And we're using I up here, the same I we have up here, so that we know that we are looking at the same number on the list. And if the doors to cells is smaller than shortest path so far, so shortest path so far, remember, is either going to be infinity or the shortest path we found so far. So if it is smaller than that, we're going to run these two lines of code here. All right, so the first line of code we have is goal door equals door checking now. So the way we have this written kind of is just, it's going to go through all of the doors, and if it is the shortest one so far, we're going to save it. And if we find a shorter path later, it doesn't matter, we're just going to save it on top of this one, and we'll forget the old one, and that will be the shortest path so far. And then we're going to have shortest path so far equal door checking now dot get component AI path door doors to cells I. So basically what we have up here, which we were comparing against shortest path so far, and if it is smaller, so basically if we found a path shorter than the path that we thought was the shortest so far, then we are going to save that as the shortest path so far, and if we find a shorter path later, we will just overwrite what we have written right now, and then that way we will find the shortest path out of all of the possible paths. So yeah, I think that is all of the script that we're going to be going over today. So now I'm going to cut the green screen and go into Unity and show you how to do that inside of Unity. Alright, here we are inside of Unity. Now the first thing I want to do is actually create an enemy. So I'm going to first create a material, and I'm going to keep it as diffuse, and I'm just going to set this to a bright red so that it is easy to see. And now I'm going to go up here to create other, and I'm going to create a sphere, and let's zoom in on that, and that's right where I want it to be. Now where, oh, new material, and let me rename this. I'm going to call it enemy red, whatever. Okay, so we have this. Now we need to set is trigger to true. Actually, no, we don't need to set that to true. We need to add a rigid body to this. So create other, not create component, physics, rigid body, and I'm going to turn use gravity off, and I'm going to just freeze all of these. So that way, now we still have access to all of the collision functions, but our rigid body shouldn't actually move and be physical, which is what we wanted to do right now. We just wanted to stay where it is and just save the cell that it's in and find out where the player is and how to get to that player. So what do we need to do next? I'm pretty sure that's everything we need to do on the enemy. So now let's create an enemy script. So create JavaScript enemy movement script, and let's open that up. And where is it? There it is. Now we got a nice fresh new script. So first I'm going to edit the player movement script. So the first thing I'm going to do is just do var current cell and game object. And now let's go down to, do we already have a on collision stay, on trigger stay? Here we go. So let's go ahead and put this right at the beginning. Why not? So we're going to do if what was it? Hit trigger dot tag equals AI path cell. And let me double check in Unity just to make sure that is what the tag was. AI, oh, okay, lowercase p. Gotta pay attention to that. The lowercase and uppercase can screw up everything. Then we're going to do, if that is true, current cell equal hit trigger dot game object. Now make sure game object is lowercase because we're accessing the actual game object that this collider is attached to. So let's save that and let's go into Unity and give that a run. So I'm just going to take the player, where am I? Okay, and I'm going to go in here. So I just really need to walk in the door just to see if it's working. Player capsule, go down to current cell, I'm going to click it, then I'm going to click that, and then actually I'm going to double click it, and voila, it has saved the cell that we just walked into. So that script is working. So now let's go back, and now let's work on the enemy movement script. So let's do the exact same thing that we just did to the player movement script. So var current cell game object, and we're going to do function on trigger stay or enter. I remember I had it set to enter. I don't remember whether it should be enter or stay, but I'm pretty sure they'll both work pretty well. So hit trigger hit caps locks there we go, collider, and opening closing bracket, and same thing as the player movement script, if hit trigger dot tag equals AI path cell current cell equal hit trigger dot game object. So just like the player movement script. So now let's give that a play, and let's click on our enemy, and I forgot to attach the script to it, and I also forgot to name it enemy as opposed to sphere enemy, because we're not going to be able to find it very easily if it's called a sphere. And then we need to attach the enemy movement script onto it. That is an important step. So now let's play it. Now we can see it is filled AI path cell. We click it, it highlights over here, we click that, and that is the one that it is currently in. So we know that that is working. So let's give that a save. And now let's go back to mono-develop and let's create the rest of our variables. And I'm going to go over here and cheat and figure out what those variables are. The player movement script, the player cell, so let's start with those. Var player movement, I'm going to, I gotta go back, because when I did that autofill thing, it turned it to a capital P, and I want it to be a lowercase p, and it is of type. Now I can do autofill because that is a capital P. Awesome. Alright, now var player cell game object. What was next? Goal door. Game object. And what was next? Shortest path so far. And we'll leave that blank for now. And then we just have wait to start. And we're going to have that set to 5. And I'm going to go ahead and hide that in the inspector. Now, there's a lot of variables that I should hide in the inspector, such as shortest path so far, goal door. Every one of these, actually, now that I think about it, all of these should be hidden in the inspector. But I'm going to wait to hide them in the inspector because it's pretty useful to have them in the inspector so that I can look at them and make sure everything's working correctly. So later on, when I actually finalize my whole project, I'm going to hide all of the variables that I want hidden. But for now, I'm going to leave them visible or leave them as normal variables so that I can take a look at what they're doing. Now let's do function awake. So what do we do first? Shortest path so far set to infinity. Shortest path so far equal mathf dot infinity. Alright, what's next? Player movement script equal game object, and we want to make sure we do the class dot find with tag player dot get component player movement script, and that'll do, and wait to start equal 5. Why can't I spell? Alright, now we're ready to go inside of the function update. Alright, so what was the first thing we had inside of function update? I believe it was an if statement, which was if wait to start is smaller than or equal to 0. Let's put a space there. Smaller than or equal to 0, then we'll run all the code inside of there. And outside of that if statement, wait to start minus equal 1, not 0, minus equal 1. And then, let me double check, make sure I got all that right. Yeah, looks like it. So now the first thing we have inside of here is player cell equal player movement script dot current cell. I believe that's right. Yep. And now we're going to do a for loop. So for what, do I need a var in there? Var door checking now. Door checking now of type game object, and we're going to have that swap through let's see, current cell dot get component AI path cell script, and we're going to access the array doors. Let me double check, make sure I got that right. Yep. I double check to make sure I get things right a lot. Alright, and what do we have inside of there? Another for loop. And we're going to create a variable inside of this one called I, and is of type integer, and we're going to have that start at 0. And then the condition is if I is smaller than or equal to what was it? Door checking now dot get components AI path door script dot cells dot length minus 1 I plus plus, and there is our second for loop. Let me make sure I got that right real quick. Yes, I did. Okay. So we're declaring the variable I of type integer. We're starting it at 0. And then as we have right here, I++. So every time we go through all of the code that we're going to be putting inside of here, I is going to increase by 1. And it is going to continue to loop through all of the code that we put in here as long as I is smaller than or equal to door.checkingNow.getComponent AIPathDoorScript.cells.length. So basically we're accessing an array that has saved all of the cells that are in our current scene according to this script here, and I believe we have it up here. Yep, cells equal GameObject.find objects with tag AIPathCells. And then we're getting the length of that. So basically the number of cells that we have in our scene, and we're minusing 1 because arrays start on 0. So now let's take a look at what is going to be inside of this for loop. Okay, so if I gotta check that again. Goldfish memory. Alright. Door checking now. Door checking now. Dot get components. AI path door script. Dot cells. I believe. Did I get that right? Yes. Equals player cell. So up here we're looking at all of the doors that are physically in contact with the cell that the enemy is in, and every time we look at each of those doors we're going to go through the list of all of the cells in the game and look at all of those cells according to the cells array that is inside of each of those doors. And once we have found the cell that we are looking for, then we are going to if, and I remember all of this was exactly the same. We're accessing the script, and then we are going to do doors to cells. I believe that's right. Was it called doors to cells? Yes, it was. If it is smaller than shortest path so far, then we are going to run these two lines of code, which are goal door equal door checking now, because that is the shortest path we have found so far, and set shortest path we have found so far, so we have something to measure this against, equal, and I'm going to go ahead and copy and paste this, because this is the shortest path we have found so far. And there we go. I believe that is all the code that we need, so let's go into Unity and give this a try. Alright. So I'm just going to go over here, and then I'm going to walk into here, and let me highlight the enemy. Let me get him. I'll find him on the list. Okay, here he is. Enemy. And goal door, none. Okay, player cell, AI path cell. Okay, it's in the right cell. Okay, let's problem solve. What is wrong? Oops, not over there. Mono develop. Okay, so I think I have found the problem, and that is that I forgot a very important line of code, which is this line right here. Shortest path so far needs to be reset to infinity every time we run through this whole for loop. Because let me show you real quick what happens when I play. So I'm going to go in, I'm going to run the player into here, and now let's take a look. Shortest path so far is really, really short. It is in the negative numbers, which is not possible. So let's go into monodevelop and let's add shortest path so far equal mathf dot infinity. Alright, now let's give it a try. It's going to be really embarrassing if it doesn't work. I'm going to feel very ashamed of myself. It seems to not be working still. I think I do know what the problem is. Let me go up here and change this to a float. Now let's save that. And now let's try. Okay, first I think I have a good feeling about this. I think it's going to work this time. It looks like it worked. So let's click on the door. Click on it here. There it is, it worked. Yes. So, I guess there are the two problems. First of all, I forgot to set the shortest path so far back to infinity. And the second problem, apparently integers can't save infinity. Okay, I don't know why an integer can't be infinity, but whatever. I guess we have to set that number to be a float, which isn't a big deal. So let's go to enemy. Now that I have moved the player over here, when I click on door, it highlighted the right door. So it knows which way to go to follow the player. So now I think we have a working script. So cool. I guess this has been ETSKI Tutorials FPS 1.34. In the next episode, we will be... What are we doing in the next episode? Oh, we're going to have the enemy very simply follow the player. So the enemy is going to go in a very, very straight path directly to the player. So it's going to go from door to door to door to player. So we're going to create very basic movements of the enemy. Later on, we'll be randomizing the movements, and then we'll be making the enemy movements ready for a crowd simulation scenario when we have multiple enemies. So that's what we'll be doing in the next few episodes. So the next episode will be making the enemy move and go towards the goal door, and then it'll go to the next goal door, and then once it is inside of the same cell as the player, it'll just move straight to the player. So then we will have an enemy that just always follows the player, and we'll always be able to find the player if the player is inside of these cells anyways. So yeah, until that episode, I'll see you guys later, and keep making games.